So we're going to start discussing polar coordinates now. So the idea is, what you're used to is rectangular coordinates. And with rectangular coordinates, you represent a point with a pair, x comma y. And so now we're going to use a new system called polar coordinates. And so you represent a point with a pair, r comma theta. And so one thing we should point out is that with rectangular coordinates, there's a unique way to write, or I'll say represent, to represent a point. There's only one way to write a point, a particular point in rectangular coordinates, but over here in polar coordinates, there's a infinite number of ways, of distinct ways to represent a point. All right, so let's look at some of these points now. Start with our first example. Let's plot the points whose polar coordinates are given. So let's start with part A, the point 1, 5 pi over 4. So this first entry, this is your r. Second entry is your theta. And when you plot points, you always are going to start with this theta over here. So the first thing you're going to do is you're going to go to that angle. So I'm going to go over here to 5 pi over 4. That lands me right there. And then you're going to go out a distance of 1 from the origin to get your point. So my point would be maybe right there. Okay. All right, let's plot another point. 2 and 3 pi. So again, you're going to start with your theta, 3 pi. So I'm going to draw my axis here and go out that angle of 3 pi. So 3 pi means I would go 2 pi once around, and then you go pi more, so you land over here, and then you go out a distance of 2, so right there. So it's actually going to be on the x-axis, my point. Okay, let's plot 2 more. 2 and negative 2 pi over 3. So again, you start with your angle theta. In this case, it's negative. So let's draw our axis. Because we have a negative angle, we're going to go in the opposite direction. So we're going to go over here, go this way, negative 2 pi over 3, and then go out a distance of 2, somewhere right here. So here would be my point, right there. All right, now let's plot one final one. Negative 3 and 3 pi over 4. So again, start with your angle theta. I'm going to be in the second quadrant. 3 pi over 4 lands me over here. But notice now my radius is negative. And what do we do when we have a negative radius? You've got to push through the origin to the kind of opposite quadrant over here and go out a distance of 3. So my point would be over here. So as I mentioned earlier, a point can be represented in many ways in polar coordinates. So let me talk about how to find those. A point that's represented by r theta can also be represented by, I can add multiples of 2 pi, so theta plus n times 2 pi, so I can add or subtract multiples of 2 pi to my angle. Or I could change the sign of my radius, I could flip it, but then I need to add or subtract an odd multiple of 2 pi. Add or subtract an odd multiple of pi, so 2n plus 1 pi. And then here, where n is any integer. So if I add even multiples of pi, the radius would stay the same. If I add odd multiples of pi, your radius is going to change signs.